Hello everyone, this is Dr. Esperanza and welcome to my channel, and today we're going to be working on how to teach simulation to students. And welcome to my lecture, and I'm going to be using simulation and TI-84 in teaching my statistics students how to make an unbiased decision using technology. What I love about statistics is all the math work that we are learning in statistics. It makes sense. And those are applied mathematics that you're not only applying for engineering. If you learn statistics, you can major in liberal arts and still use statistics, because we need research, and in research you need statistics. And that's what we're going to be talking about today. I've been talking about so much about statistics, and I have bullet points about what statistics can do. 1, predicting weather. The models, when we say models, it's equation, basically are functions. They use it to predict weather or patterns based on what they're seeing from the satellite. Another thing that statistics is doing, winning YouTube silver play button. That's actually, and we're going to be learning it in this series of workshops. We're going to be learning some statistics skills or math skills that we can apply if you want to achieve a silver play button like what I have right now in statistics. And in medicine, you're not going to be able to create drugs, not Breaking Bad drugs, but you're not going to be able to create prescription drugs without statistics, because it takes time, simulation, and statistics also used in creating drugs and predicting leaders. Obviously, come election time, you will see a lot of statistics on elections. Who's gonna win? How is he gonna win or she's gonna win? So it's all about statistics. And what we're going to be working on today, and it's also something that is extremely useful in statistics, is this: convicting criminals. Yes, we can use statistics to be able to make a sound judgment or an unbiased judgment using numbers and patterns, and that's what we're going to be using. So predicting weather, winning YouTube silver play button, creating drugs, predicting leaders, but right now we're going to be convicting criminals using this. So we're going to be using our TI-84 to convict criminals. And this is what I've been telling my students in a statistics class, that in a stats class, 101% of the time it's going to be a word problem. And most students, they don't like being in a math class because they hate word problems. Well, I did when I was younger. And today we're going to be working on a case, and it's going to be a case on hiring discrimination problem. So we're going to be using numbers and statistics and your calculator to decide whether we are going to be convicting or acquitting someone or a group of people today. So this is going to be our case. So our case is hiring discrimination problem. So in this particular case, an airline has just finished training 25 pilots. 15 of them are male and 10 of them are female. So to become captains, they need to be trained. That's why they chose them. And unfortunately, only 8 captain positions are available at that moment. Now, the airline managers announced that they will use a lottery, so they will be doing it in random out of the 25 trainees that they have to determine which pilots will fill the available positions of being a captain. So out of the 25, they will pick 8. Now, the names of all the 25 pilots will be written on an identical slips of paper, and the slips will be placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been identified. So it's pretty random. Now, this is the case. So this particular airline were able to produce the 8 captains that they're trying to choose out of lottery. Now, a day later, managers announced the results of the lottery. Of the 8 captains that was chosen, 5 of them are female and 3 of them are males. So some of the male pilots who weren't selected suspected that the lottery was not carried out fairly, and it's biased, and it's rigged, basically. So one of these pilots asked us for advice of whether to file a grievance with the pilots union, because of what's happened. Now, do you understand why the male pilots are a little bit skeptical about the result?
Yeah.
Yeah, by looking at the numbers,
There's more males.
there are more male pilots than female pilots, but in their lottery,
There's more females.
there's more female that was chosen. So, this is the thing. Do you think that the male pilots have a valid claim of a hiring discrimination case based on this result that was said to be random? Now, if we don't know statistics, we can quickly say that yes, they have a valid claim because numbers is telling you that it's not possible. So, of the 8 captains that was chosen, 5 of them are female and 3 are male. And it's a little bit suspicious for the male pilots because there were only 10 female trainees and 15 male trainees, right?
Yes.
So 1/2 of the females were chosen, but only a fifth of the males were chosen?
Yeah.
Mathematically, yes.
Okay.
But
As a whole.
according to them, they did it in random.
Okay.
And we want to see, or the male pilots want to see if they have a legitimate claim on the... But right now, yeah, it looks like it, right?
Yes.
Let's see. So we need to construct a mathematical or scientific way on how to decide whether they have a valid claim or not. And that's what we're going to be learning today. How we're going to use this calculator and statistics to decide whether the male pilots have a valid claim. So that's the first hypothesis. Hypothesis 1, the male pilots have a legitimate claim in the sexual discrimination case. What do you think is the hypothesis number 2?
They don't have a legitimate claim.
And that's how we write hypothesis in mathematics, or mathematically. It's always going to be a complement of another claim. So this one, they have a legitimate claim. This one, they have no legitimate claim. And to do that, we're going to be simulating this random hiring scenario using our computer or calculator. So we're going to be doing this on our own, and we're going to reenact what happened in the lottery process. So what are we going to do is we're going to simulate 10 female pilots and 15 male pilots using technology, and that is going to be our TI-84. So we're going to be using this. Remember, in the hiring committee, what they did was they wrote down all their names, those 25 pilots' name, in a piece of paper, and then put it in a hat, and then pick 8
So it's like a
papers, which is random, right?
Like John leaves that.
Yeah, and it's pretty random, and we know that it's random. But looking at their result, it doesn't look like it. So what we're going to do is we're going to simulate that and
see what happens.
see if,
They're legitimately picking.
yeah,
If it's like almost possible to replicate.
almost possible to have more female than male. Because in statistics, I know you're already in sampling. The more samples you have, the better prediction you are going to have when you are working with predicting outcomes. So we're going to be creating simulations using your calculator. And to do that,
I said I would know about that.
we're going to learn how to simulate using our TI-84. So in your TI-84, you're going to be using this push math, go to PRB, and go to number 5. And you will see random integer. Randint is the function in our TI-84 that will simulate this particular scenario using the calculator. Now, how is this going to work? So in this calculator, we're going to be using or counting female pilots in our group. Now, how are we going to simulate that? Okay, in your calculator, you have this, and it will require you to produce 3 numbers. This one will be the minimum number.
Is that what it's called, Loa, on ours? It's like Loa, upper, and N.
Well, mine just has.
So you have different calculators, but it's still going to be the same.
Yeah.
So minimum or lower, maximum or upper, and this one is the number of elements or integers that you're going to pick out of your integers. So we need to assign digits first because we're using numbers and technology. So this is what we're going to do. So our female pilots will be represented by the numbers 1 to 10. So we're assigning digits. So if the numbers 1 appeared, 2 appeared, 3, 10, and so on, they are female. And if the number 11, between 11 and 25 appeared, we are selecting males. So the minimum number of numbers that we're going to be playing with is going to be from 1 up until 25. We're just going to use, or your calculator will only produce numbers from 1 to 25. They're not going to show 26, 27, 28. And your calculator will also be picking how many pilots were hired. 8 pilots were hired. So on your first simulation, you will push enter and see what you will find. Do you see a series of numbers inside a bracket?
Yeah.
Okay. So 1 to 10 are female, 11 to 25 will be male. Can you please count the number of female that you randomly picked using our simulation? I'm going to write mine and then you write yours.
And we're writing the number of females, right?
Yes, we're just concerned right now with the number of females. And that's what I'm going to be producing in my calculator. 1, 2, 3, 4. So I have 4 on my first simulation. I hired 4 females. How about you? How many females did you hire?
3.
How many females did you? 3. Okay. If we're going to use our simulations, which is just 3 simulations, it's not enough. We need to have more. So we're going to be producing more. So push enter again, and that's another simulation. Or you can redo the process. Now I got, for my second simulation, 1, 8, 1, 1. So I have 4, 2, 3, 4, 5. Okay. So how many simulations do we have now? I have 3 here, you have 3. We're gonna have more because I want to see a pattern, because the more simulations we have, the better we're gonna have a better pattern of what we're looking at. So let's do
10 each.
Let's do 10 each. I'll do 10, you do 10. It's all about graph, it's all about data, it's all about numbers. It would happen. So what we're going to do is we're going to do a dot plot.
We love a good dot.
Yeah, we know about this.
We know about these.
So I'm going to do mine, you're gonna do yours, you're gonna do yours after. Come here and let's plot points. So I'm going to do 4.
Ooh, intense.
4, 4. Okay. Yes. Is it 30? Okay. All right. So.
You have pen now?
Huh?
Oh, yeah, I was gonna steal your pen after you.
So, out of 30 simulations, we're able to produce this dot plot. Now, in this case, in the case that we just had, how many female pilots were hired?
5 and 3 males.
5 of them were hired, and then 3 males were hired. Now, so if we're going to be counting number of female pilots based on our simulations that were hired 5 and over, we'll be able to see something.
Ooh, that's pink too.
Yes.
Wow.
Is this supposed to? Yeah, there. This is what I want. Okay. And let's count the number of times we hired
5.
females
Okay.
that is over 5, over 4. I-
Yeah.
Oh.
Over.
How many? Oh yeah, over 5 because
Okay.
they hired 5 females, right?
5, right? Yeah, we could say 5 too.
Yeah,
So
so
you
5 and
five
over.
in that. Okay.
Yeah, 5 and over. So in this case, how many of them did we hire?
Sorry.
Come on here.
No.
So we hired 8 female.
No, it was 8 times. 8 times did we?
Oh yeah, 8 times that we hired
More
females.
5 or more female.
5 or more female based on our simulation alone.
Yeah.
And if we're going to find the percentage of the female pilots that we hired that is over 5, I mean 5 and over, it will be 8 all over 30, right?
Yeah.
What is 8 over 30? What's 8 divided by 13%? What is 8 out of 30 in percent form? Point what? You have a calculator. What's 8 divided by 30?
28-ish.
Point,
0.26.
26. Alright.
just 0.26? Oh, dang.
It's 0.26666 repeating.
Wow.
Sorry.
So let's say 27.
Yeah. 27%.
Based on our 30 simulation, the probability that we will hire more than 5 or more female pilots is about 30%. Do you think it is unusual or not? Well, in this particular simulation, I would say that the likelihood that they will hire more than 5 female pilots by random alone with 30% is a pretty good chance of happening.
Oh, really?
Yeah, that's
Oh, okay.
huge.
Oops.
I mean, by random
Yeah.
selection alone,
Yeah.
it's huge. About 30%.
30%. Okay.
Do you understand the logic behind the dot plot?
Yeah.
Yes.
So the dot plot, we simulated 30 simulations of hiring pilots in random. And in our simulation alone,
8 times. They
8
hired
times that we hired
Wow.
more than
more than 5.
5
Oh.
females.
Five.
Yeah.
So there is a chance
Yeah.
that it might happen.
Yeah.
And you also need to think about the simulations we had.
30.
30. It's still small. If we do this over and over and over again, let's say 100, do you think we'll have more of the female pilots being hired over 5?
Yeah.
I mean, hiring over 5 female pilots in that many simulations?
Of course.
And this is why we're doing statistics. If we do this over and over again, this is what will happen. Out of 500 simulations based on a computer app, this is their simulations. And you will see that this many is the number of female pilots that will be hired 5 and over, and that is a lot. Why? Because in statistics, we have a rule, the unusual rule. There is a certain threshold for you to say that something is happening by chance alone. And the threshold is?
I'm gonna see. Oh, so anything. So what you're saying is anything over 5%
It's
would
like
it's
possible.
reasonable.
It's reasonable percentage that it might happen by chance.
Okay.
But
it was,
if your percentage is less than 5%, then you will be suspicious. Wonderful, right? There is a certain percentage in statistics. And this is what we're going to be learning even more once we work on hypothesis testing, like actual scientific way on how to create or how to write an experiment mathematically. But right now, this is how it's happening. I mean, this is basically how statistics is working on how we can use numbers to convict or not convict criminals using simulations. And again, this is Dr. Esperanza. Thank you for watching my video, and if you happen to like my lesson today, please like, share, and subscribe to my channel. Thank you. Bye.